Hello and welcome back to the Dodgy Engineer channel. I am Joseph and today we're going to be building something slightly dangerous. We're going to be building a spot welder, but not the fancy kind with MOSFETs or proper control or safety. Instead, we're just going to be using a big fucking solenoid, by which I mean a relay. I said solenoid, I meant relay. There's a solenoid in it. Anyway, let's get started. So here's the circuit that we're going to be using. This is credit of someone whose channel I can't remember. I will link them in the description and probably put some text on the screen. What we're using for this is a car battery at 12 volts, an on and off switch, chunky resistor, a capacitor to activate the solenoid in the relay for a very short amount of time to make the spot weld, and a diode for flyback protection. Basically, an inductor, which is any coil, will try to keep the same amount of current running through it. And what that means is that if the current is suddenly shut off by the capacitor running out, for instance, it will try to generate current moving in this direction, which is very bad for a polarized capacitor which wants positive here and negative here. So what we're doing is adding this diode across it to safely dissipate that current back around, creating a mini short circuit. The way this entire circuit operates is that the battery will charge up the capacitor, then this SPDT, single pole double throw switch, is clicked over when I press a button, and the capacitor will discharge into the relay, causing it to activate for a very brief period of time, which will allow the negative probe straight off the battery to very briefly make a connection. Now these probes are going to be attached to some copper nails or copper sheeting, which are going to be very close together, two little points like this, and they are going to spot weld whatever sheet I put under them, which is probably going to be nickel sheet over some 18650 batteries. So let's get started. Now what you need for this project is no sense of safety. You need a switch for the on and off, you need a box conveniently full of the stuff that we need. Don't need that. Here's the solenoid, or the relay that we're going to be using. I keep saying solenoid, I mean relay. Please just comment every time I say solenoid instead of relay with an angry message. This is from a car. It's good for about 80 amps. It's going to draw more than that, or it's going to pull more than that, since we're shorting it out, but it should be fine. Here's our charge resistor, so that the capacitor doesn't instantly draw a huge amount of current out of the battery. Here's the capacitor we're using. It may not be big enough, but we'll see. Also got some assorted lugs here. And here is that single pole double throw switch. This is actually a very ancient micro switch. As you can see, there's a little button on there. I'm just going to be mounting this ideally on the probes so that I can press it with the same hand. Some nice ASMR there. Anyway, back to actually doing things. And here, right in the bottom, is the diode that we're using. It's probably undersized, but it's worked like 3 times when I tested it, so it should be fine. We also need some very chunky cable. So this is 8 AWG, or 8mm squared cable. I believe that's the crossover point in the measurements. I've got red and I've got black. The red is slightly less flexible than the black, so I'm probably just going to use the black for the probe section. But the red is definitely going on the battery section because I do not want to mix that up. Right, well, my phone was getting hot, so I've switched the frame rate to 30 frames per second. But this time around, I've actually remembered to press record on the microphone. So you should have slightly better audio. Anyway, the next step in this process, or rather, the first step in this process, other than listing the parts out for you to see, is to attach the diode to the terminals of the solenoid. Of the relay. Anyway, this is done by using some crimps because I don't want to solder 2 threads. I want to die. I always miss the actual metal of these crimps. As you can see, I've done a terrible job of this and am now going to be soldering it to the crimps. I'm a professional, trust me. Well, actually no, I'm not. I'm a student. I can't even claim I'm a professional. Come on, soldering iron. You can heat up faster than that. Clean, clean, clean. That tip is disgusting. Alright. Look at that. Perfect. Perfection. Absolutely wonderful. Alright, now let's move on with the other important stuff. So this length of cable should be coming in from the positive terminal of the battery. And where the heck did I put my schematic? Ah, there it is. There we go. Positive terminal of the battery and to the probe. So I could just pass it straight through the box and take a little nick out of it to tap the switch off. Well, I ended up doing a little bit more. First of all, I've attached some wires to the on-off switch, and one of these leads directly to the resistor, because the resistor is going to lead to the button, which is going to switch to the capacitor. The other thing I've done is attach one of the leads of the capacitor to one of the leads of the coil, and the other one is going to run out of the case along with the other leg of the resistor and a lead from here to the SPDT switch. Oh man. It caught. Sorry about the wind noise now. I've got 2 fans on and my computer fan is ramped all the way up because today is extremely hot. But I'm gonna try and get this done now. So as you can see, I've actually drilled some holes in this case so I can start mounting the components to it. So let's just start doing that. I'm gonna start off by mounting the switch, I believe. Well, I don't just believe, I do know, because I am doing it now. But this should be the easiest part to put on. There we go. And I shall time-lapse forward now because I'm too lazy to continue filming and voicing over at the same time. My phone is still overheating, so I'll try and keep this brief, but the next job I've got to do is to feed the red wire through from the battery end out to the probe end, and then solder this wire onto the little tap point that I've made in the red wire. I'll just put that in time lapse now so that my phone doesn't continue to die, and see you when I've done that. Now what I've got to do is feed the black wire from this end of the relay out to the probe end. So for that, what I'm going to do is use this cut length that I have, feed it through here, put a crimp on this end, and then connect it to this terminal here. In the course of attaching the wires to the terminal block here, I've noticed something pretty important. See, this red wire is incredibly stiff compared to the black wire. So I think just as a quality of life improvement, I'm going to attach this terminal block quite near the case and run the red wire into one side of it and then have the rest of it be black wire all the way to the electrode. So I've wired up the terminal block to the more flexible black cable, and I've cable tied the micro switch to the end of the terminal block. Now what I've got to do is wire up the contacts of the micro switch to the lead of the capacitor, one end of the coil of the relay, and one end of the resistor, which comes off the switch. I believe I've finished the wiring of this now, so what I'm going to do is connect it to my lab power supply and see if I can make the needle of this multimeter jump when I activate the spot welder. Alright, I've switched the power supply on. I'm just going to switch this on and hope nothing shorts out. And let's see. Alright, nothing seems to be happening, so something has gone wrong here. Oh, there we go, something's happening. Yeah, that appears to be working. I'm not sure what it was doing the first few seconds there. But now it seems to be charging the capacitor and clicking the relay, so that's excellent. We've got to try it out with some proper electrodes next time. This is the first test of the spot welder. I'm just going to connect it up to the battery, then switch it on and try to spot weld these two little nickel strips I've got here. And I'm going to make sure that these are both tightened down pretty well because it's going to be drawing at least 100 amps, I'd assume. Yep. Alright. Switching it on now, and we'll test if this is working. Yep, you can hear that clicking, which means that it's activating the relay. I might have to bring them a little closer. Hey, that was a nice one. Well, that seems to be a bit too powerful, so I think I might have to reduce the size of the capacitor, but it definitely spot welded them together. Look at that. Now let's, oh, it also left a nice big burn on the wood here. See there? Let's try that again. Fold it over again. Wasn't contacting. Hold on a sec. I think my electrodes have got coated actually. Just look at that. There's a little deposit on the end of the electrode there. So it might actually not be making good enough contact, and I might have to find some different electrodes too. Hey, there we go. Looks like the electrodes are fine. I just need to reduce the time that the relay is contacting for, and we should have the right power. The ultimate test of this spot welder is going to be whether it's able to weld together 18650 cells into a pack, since that's what I actually designed it to do. So what I have here is 8 LG Chem MJ1 cells, and I'm going to try not to blow them up. We'll see how it goes. So here they all are, and for this pack I need them all to fit inside this box. Now anyone who's familiar with this might already be able to see what this is going to go into, but I'll make that a separate video once I'm actually doing it. Suffice it to say, for now, it's going to be a little bit cramped, and I'm going to also need to leave some room for BMS wires and a BMS, just to make sure that it doesn't come out of balance while I'm using it over the years. I'll start cutting up the nickel strip, and we'll see if we can squeeze it all into this. Fuck me, that's not good, no. Not sure if you can see that, but it burnt all the way through the top cap on that one. I think it's safe, because it's spaced out, but holy shit, that's terrifying.
What made it do that?
See, that's the thing, I don't know. It's just one of the perks of building your own spot welder. You have no idea when something like that's gonna happen. Oh no, I think I welded a bit too close to the edge of where there's like a gap in the little cap. It's not heating up or anything, so I think we're good. Good news is we're nearing the last few welds. I've just got to do these, and then I've got to weld the thermal fuse into the middle of the pack. And we'll see. See if I survive. Holy fuck balls. That's why. Ha! I understand now. So my spot welder has failed. I believe that the problem is either the switch has permanently closed the relay, or that the relay itself has welded itself shut, which is entirely possible. So I'm just gonna pause doing this for now and try not to destroy the remaining cells. And I'll get back to you when I'm not doing this stupidly.